And we are going to have Rachel Murchland now from the City of Mitcham, and they have been thinking about how they can apply this science and research to real world scenarios. They've been working on a project to consider the practical application of smart stormwater systems to improve their network efficiencies, the capacity, but also infiltration and reuse. So I think we're definitely getting multiple benefits from these types of projects. Thank you, Rachel.
Thanks, Belinda. So I would just like to acknowledge that I'm also coming to you from Ghana country, and that I value and hold in high regard their connection to country, and pay my respects to their elders who have been caring for this land for the past 60,000 years, and pass on those respects to the elders from wherever you're connecting from as well. I'm here to talk about the City of Mitcham's smart stormwater collaborative work that we've done with the University of Adelaide, and how I suppose City of Mitcham's involvement has influenced the outcomes of the theoretical project and helped to sort of tailor the modelling and the practical outcomes so that council can get something that is tailor fit and helpful to the council moving forward, and also what we're doing following completion of that theoretical project. So we partnered with University of Adelaide in 2021, working on the opportunity to model the smart stormwater storage to try and reduce peak flows in a real catchment. If I recall correctly, we were sort of asked to look for a catchment that we could that was well defined with opportunities to install storages. And we took the opportunity to look at this catchment that Mark and Holger mentioned in Pasadena, where we've already installed some water sensitive and design measures to daylight a creek in that catchment. So the chosen catchment was also useful because it included a confluence of multiple similar sized catchments. So that was, I understand, was helpful in comparing the benefits of the storages across each of the catchment areas. And we took the opportunity to incorporate into the project the combined improving greening and cooling elements for the project, so we could model how long we could increase the flows through that Pasadena biodiversity corridor shown in pink there, to try and increase the infiltration opportunity, so the length and duration of flows flowing through that corridor. And we ultimately were looking at this particular location, trying to reduce the downstream peak flows at that point. So as a modelling and optimisation exercise, there was a lot of things that we learnt during the process, and a number of things that council, so from our side of things, had to consider from a more practical perspective. That we had to consider things like pipe blockage and maintenance requirements. And so in those considerations, we had to limit minimum pipe size that could be utilised so that we could maintain, reduce the potential for blockages and make sure that the pipes were maintained, so that influences the model. We also had to look at the catchment in terms of where we could build storages. So we walked with the University of Adelaide, we walked the catchment, looking at what available space there was, what realistic storage volumes we could achieve in each of the sort of locations that we selected. And Mark mentioned the extreme amount of storage opportunities we had, so we were very fortunate in that way. But the downside of that was that there was so many options, there was so many variables, so we had to define a lot of the parameters to make the modelling effort a bit more manageable. So we had to sort of prioritise things. We had to, we would have loved to have had to minimise the storage volumes and minimise the downstream flow rates and maximise the outlet pipe size from a cleaning and maintenance perspectives, but those were all trade-offs. So we really had to prioritise what the most important outcomes for the project were, and we had to consider the practical implications of those choices as well. So in terms of our preferred locations for storages, we had to consider, I suppose, costs and safety, maintenance and accessibility. We had to consider the usage of the reserves from a community perspective. All these things meant that we had to prioritise some aspects and trade off some other things. So yes, I believe there were over 700,000 layouts that were evaluated, and we had to make some tough choices weighing up the different options and the peak flow rate reductions that we might be able to achieve. Mark mentioned that we ended up the best outcome that we had was having a larger storage in one catchment and a smaller one in the next, but we've ended up trying to focus on that one larger catchment and the larger storage. From a practical perspective, it makes more sense to investigate the opportunity to build that one storage rather than trying to split our focus there. So we had to make decisions on all of that, try and make sure that we were factoring that in terms of being able to potentially progress the project into the future. So the outcomes of that modelling project suggested that, like I said, we'd be focusing on that catchment to the south, putting storage in that location to then ultimately benefit the Pasadena Biodiversity Corridor, and hoping that we also determined that the best outcome would also be to incorporate reuse opportunities in a subsequent downstream reserve as well, trying to green and cool that reserve there. So it was definitely a collaborative project. The University of Adelaide had us involved really regularly, had asked us lots of questions, and it's really helped, I think, to make sure that the product of the modelling was really useful and practical for the setting. And as a result, we have also been investigating how we then might be able to deploy such an option. And so we've continued to investigate that opportunity. And this particular photo is of one of the potential storage locations, but it is, as you can see, it's quite a natural creek line. It's fortunately not very incised at this location, but we've got a lot of factors to think through. And so I've been investigating what the practical implications are for the project, and how we might conceive of an actual on-ground work in these spaces. So we've been looking into site feasibility. The modelling obviously was looking at storage options, and so we, when we walked the site, we looked at opportunities to do above ground storage or below ground storage, and we ended up assuming that above ground storage would reduce costs. So that's sort of where we're hoping to proceed with. We have to consider how we might monitor the flows coming in and out of the storage systems, but in a natural setting, how do we install those and maintain those? We're having to work through practical considerations for cleaning and maintenance, and how and what style of gross pollutant and sediment control measures we might be able to employ. Also, the location for those storages needs consideration from a maintenance perspective, because there's the higher up in the catchment we get, the less accessible those storages might become. We've needed to think through the environmental impact and the opportunities that trees in the City of Mitcham, and hopefully everywhere, but trees in the City of Mitcham are very important to residents and to council, and we really want to design a system that would work around the trees rather than having to remove them. So looking into the feasibility of doing that. There's operational and depreciation costs without other existing systems to rely on. We haven't had a lot of information in that space, so I reached out to Glenn Ricketts from the City of Marion, who helped me with some background data on what they've been doing in their with their wetlands. So that's been really helpful. Thanks, Glenn. We're looking at services, what would be required to control an actuated valve and control the flow rate from those storages, and what services would need to get there to get to that location, and practicalities of getting services to that site. Making sure we've also got redundancy in the system so we don't create flooding issues in trying to avoid them. And also investigating opportunities for additional works to cool and green the reserves and enhance livability. We want to make sure that if we can proceed with this project, that that it works not only from a stormwater perspective, but also works for the community. So opportunities to improve the reserves in a holistic sense. And that's pretty much me.
Thank you, Rachel. I think even though you can sort of get through the optimised solution through the work the University of Adelaide are doing with their models, you've then still got lots more to consider in terms of feasibility and practical implementation. So I think that's really important to note.